For thousands of years, a diagnosis of leprosy was a death sentence, not necessarily of the body, but of the spirit. Banished to colonies and hidden behind veils, the afflicted only had one desperate hope: the acrid, nauseating oil of a jungle fruit that was just as likely to kill you as it was to cure you. I'm Megan Brame, and on this episode of The History of Plants, we're venturing into the dense tropical glens of Southeast Asia to uncover the botanical enigma of the Chaulmoogra tree. But to see how this tree became the primary, yet imperfect, defense against a disease once synonymous with social death, we need to unlock its origins, or at least what we know of them. The botanical source of this ancient hope is the genus Hydnocarpus, specifically trees like Hydnocarpus pentandrus and Hydnocarpus kersii. Sadly, for a botanical lineage that is so important to our species, we don't have a ton of paleobotanical data on its origins. We do know it's native to the maritime forests and tropical glens of Southeast Asia, Northeast India, and Myanmar. Some fossil remains we found date back to the Middle Miocene, roughly 11 to 16 million years ago, showing the genus was well established long before humans ever migrated to the area. But we're not 100% sure there are Chaulmoogra. The tree produces a fruit that guards its secret cure well, a thick, woody-rinded ovoid fruit that looks a bit like an oversized dusty orange. Inside that protective rind are 10 to 16 seeds, which account for about 20% of the fruit's weight and hold that pale yellow acrid oil that would eventually travel the world. What we lack in fossil records, we more than make up for with the tree's linguistic trail. In northern India, it's Chaulmoogra or Jungli Badam, wild almond. In the south, it's Murati, Koti, or Surante, but its Sanskrit identity is perhaps the most telling: Tuvaraka, the enemy of leprosy, or Kushtuviri, which translates to skin disease enemy or foe. Before we continue, let's do a quick run-through on what leprosy is and how it works. Historically, the word leprosy comes from the Greek lepus, meaning scaly, and leperos, meaning a scaly man. Scientifically, it's known as Hansen's disease, named after the Norwegian doctor Gerhard Hansen, and is caused by a slow-growing microbacteria named Mycobacterium leprae, which is the most famous culprit, but a recently discovered other species, Mycobacterium lepretosis, is also now on the list. Sadly, Mycobacterium leprae has been with us for a long time, and its true origin is still up for debate. Some suggest it migrated from Africa, while other evidence, like 5th century remains in England, hints it may have originated in Western Eurasia. We've even verified the disease was around through DNA in the 1st century remains found in a shroud near the Old City of Jerusalem. However, in 2009, researchers in Balatal, India, discovered skeletal remains from the 2nd millennium BCE showing clear evidence of the disease, making it the oldest documented case. By the 6th century BCE, the Indian physician Sushruta gives us one of the first reliable clinical descriptions in the Sushruta Samhita. He called the disease kushta, noting the loss of feeling and visible lesions, and the eventual physical degeneration of the extremities. In ancient China, it was known as dafang, or the Great Wind Disease. Early practitioners described it as an affliction that attacked like a pervasive wind, causing impurities of the blood and visible eruptions. The Egyptian Ebers Papyrus and the Hebrew Bible may also refer to it, calling it a disease of impurity, or tzara'at in Hebrew, which I think I butchered pretty badly. Sorry about that. Also, while it's mentioned in the New Testament multiple times, there's some debate on whether any of these texts are actually talking about leprosy, or another skin ailment like psoriasis or later syphilis that just kind of got lost in translation. That's a lot of preamble. Sorry about that. Unlike what you may have seen in movies, leprosy isn't a fast-acting plague that eats your nose. It is much more insidious. The bacteria target cooler parts of the body, the hands, feet, face, and the lining of the nose, attacking peripheral nerves and mucous membranes. Symptoms can appear within a year, but they often actually take 2 decades to surface. Left untreated, it causes a loss of sensation, muscle weakness, or even blindness. When it attacks your peripheral nerves, it disrupts the body's ability to feel pain, which may sound super goth, but really means you don't notice when you've burned your hand or cut your foot. This leads to secondary infections and the physical degeneration and limb loss that led to such extreme social stigmas. This link between the disease and sin or impurity has been a really heavy burden for patients throughout history. When the book of Leviticus defined the condition as unclean for ritual purposes, it didn't necessarily pass moral judgment. However, later figures like Pope Gregory the Great and Isidore of Seville were less forgiving, often viewing those with the disease as heretics or targets of divine punishment. In our search for a cure, we'd tried everything from burning people, sending them away to leper islands, more on that later, or just throwing them overboard if they began showing symptoms while at sea. Basically, we needed a cure, but weren't sure where to turn. Records are kind of vague about how we came to use Chaulmoogra, but we're pretty sure we were desperate and maybe just started to tinker with plants to see what would happen. It's as good a theory as any, I guess, and it certainly beats other treatment like mercury, which definitely did not help. What we don't have in fact, we certainly have a lot of in folklore. Legend tells of a king named Rama who contracted leprosy, then seen as a mark of unrighteousness and divine retribution. He abdicated his throne and retreated deep into the forest to die in isolation. Driven by hunger, he began to eat the fruits and seeds of the surrounding trees, including the kala tree, or Chaulmoogra. His skin cleared, his strength returned, and he emerged transformed. In another variation, Rama discovers a princess named Paya, also suffering from the disease, hidden in a cave. He treats her with the seeds, and together they are healed. Somehow along the way, Chaulmoogra oil went from myth to medicine pretty early on. In Ayurvedic tradition, the oil's potency, or vira, is considered transformative. It was used to rebalance the vata and kapha doshas, clearing skin lesions and what practitioners described as impurities of the blood. Those skeletal remains from 4,000 years ago we found in Balatal also show the first traces of plant oil treatments that we think came from Chaulmoogra. But there was a catch that early practitioners knew all too well. Ancient scrolls promised the oil could heal the unhealable, but there was a dark side to this miracle. The medicine was so toxic and the raw oil so painful to process that many patients faced a harrowing choice. To take the oil orally meant enduring violent projectile vomiting and permanent stomach damage. To use it topically often yielded little to no result. For thousands of years, the world held the cure in its hands, but didn't have the key to unlock it without breaking the patient in the process. But in 1915, a young chemist unlocked that key, changing the way we handle Chaulmoogra forever. While our story began in the ancient forests of Asia, leprosy was an international crisis. It moved along trade routes and expanded through colonial contact into Africa, Europe, and the Americas. Even today, it remains a persistent problem, with hundreds of thousands of new cases reported every year across more than 120 countries. This global pressure turned what was once a localized botanical remedy into a highly sought-after pharmaceutical commodity. The Western medical world officially entered the story in 1854 when a British physician named Frédéric Jean Mouat reported successful treatments of using Chaulmoogra oil at the Bengal Medical College in India. Mouat's report sparked a voracious hunt, with pharmaceutical companies and botanists scouring South Asian jungles to secure a steady supply of Chaulmoogra seeds. They were shipping this miracle oil to the Louisiana leper home in the U.S. and all the way to the isolated cliffs of Hawaii. But as the oil traveled, its inherent flaws followed. The medicine was a nightmare to administer. The raw oil was so thick and acrid that swallowing it caused violent projectile vomiting, like I said, and permanent stomach damage. It was also too thick for the skin to absorb, so topical applications were out, and if you tried to inject it, the oil was too viscous to dissipate into the bloodstream. Instead, it just sat under the skin, forming agonizing sterile abscesses. Nowhere was this hope and heartbreak more visible than Kalaupapa on the Hawaiian island of Molokai. Starting in the 1860s, the Hawaiian government began forcibly exiling anyone suspected of having the disease to this isolated peninsula, walled in by the highest sea cliffs in the world. For the exiles at Kalaupapa, Chaulmoogra oil became a centerpiece of their folklore. They romanticized it in their stories and songs as a sacred oil and a final desperate lifeline. Yet in reality, it continued to fail them. They were essentially being injected with a thick substance that stayed in their muscles for months, providing little relief while adding a new layer of physical agony all the while shunned from society and their loved ones. Imagine just how frustrating that had to have been. We know it can cure leprosy if we could only get the delivery method right, but everything we tried either proved ineffective or came with side effects that caused just as much suffering as the disease. That all changed when a 23-year-old chemist from Honolulu found the key. Enter Alice Ball, a brilliant chemist and the first woman to earn a master's degree from the College of Hawaii. In 1915, she was approached by Harry Holman, an assistant surgeon who was tired of seeing his patients suffer from the side effects of the raw oil, so he challenged her to find a solution. Alice went to work, grinding until she was able to unlock a chemical transformation that was the missing key. She figured out how to isolate the active fatty acids from the oil and convert them into ethyl esters. This then converts the thick, syrupy oil into a thin, injectable liquid that the human body can finally absorb without nausea or abscesses. For the first time in history, there was a treatment that worked, but unlike the raw Chaulmoogra oil, its use didn't feel like a punishment. But here's where the story takes a dark turn. Tragically, Alice Ball died in 1916 at the age of 24, likely due to a lab accident involving chlorine gas, before she could publish her groundbreaking results. After her death, the president of the College of Hawaii, Arthur L. Dean, took her research, published it under his own name, and branded it the Dean method. He began mass-producing the extract, and while it saved thousands of lives and allowed exiles to finally return home, the world gave Arthur Dean the standing ovation that was meant for Alice. The truth only began to surface in 1922. Harry Holman, the man who originally gave Alice the assignment, published a paper explicitly stating that it was Alice Ball, not Arthur Dean, who had solved the riddle. He wrote, quote, "I cannot see that Dean has made any improvement on the technique as first worked out by Miss Ball." Even with that public defense, Alice's name slipped back into the shadows of the history for decades. It wasn't until the 1970s that researchers rediscovered her records and restored her legacy. Today, she is finally recognized as the woman who turned a jungle poison into a medical miracle, and the Dean method has been rightfully renamed to the Ball method. Alice Ball's ethyl ester breakthrough finally harnessed Chaulmoogra's power safely. But what is it about this tree that makes it so powerful against leprosy, and what else can we use it for? To understand why Alice Ball's breakthrough worked, we have to look at the teeth of the oil. Most oils you find in the kitchen or the lab are made of common fatty acids, like oleic or linoleic acid. Hydnocarpus carries a set of fatty acids that are chemically just weird. In 1904, chemist Frederick Building Power and his colleague Frank Gornall isolated Chaulmoogric acid from the seeds. A year later, Power continued the work with the wonderfully named Marmaduke Barrowcliff and isolated hydrocarpic acid. Then, in 1928, French alchemists Émile André and de Jouat isolated gorlic acid, a close chemical cousin that shows up in this broader family of rare plant fats. But what makes these special is that they have a tiny 5-carbon ring at the end of their fatty acid chains called a cyclopentenyl. It's a teeny tiny detail with very big consequences. The bacteria that causes leprosy has a very unique waxy cell wall that acts like a suit of armor, so most treatments just bounce right off of it. However, the structure of these acids allows them to mimic the bacteria's own building blocks, so they trick the bacteria into absorbing them, and once inside, they disrupt the cell's metabolism, effectively starving the bacteria from the inside out. But before we could get to those healer molecules, we have to bypass the tree's defenses, which isn't easy because its seeds act like a 2-part chemical booby trap. They store cyogenetic glycosides in one part of their cells and a specific enzyme, beta-glucosidase, in the other. As long as the seed is intact, it's perfectly stable. But the moment an animal or human crushes or chews that seed, the two components mix and create basically a cyanide bomb, releasing hydrogen cyanide gas. This is the tree's way of saying, step the f*** back. In small amounts, you'd notice that trademark bitter, acrid taste, but be relatively okay. emphasis on relatively, but in concentrations found in these seeds, it's a potent toxic that interferes with the body's ability to use oxygen at a cellular level, which is why the raw oil caused such violent projectile vomiting and permanent stomach damage. Ayurvedic practitioners saw that intensity and classified it. They described the oil's vira, its transformative potency, and the way it seemed to penetrate deep into the tissues. They read it through Rasa Panchaka, a 5-part profile used to describe a plant's medicinal personality. Rasa, taste; guna, physical qualities like heavy or dry; vira, thermal energy; vipaka, the post-digestive effect; prabhava, the unexplainable signature move. For Chaulmoogra, the profile was pungent and hot, used to rebalance vata and kapha doshas. In that system, leprosy was framed as cold and stagnation, so practitioners reached for fire. Across other Asian medical traditions, the plant had a similar reputation as an aggressive antimicrobial and anti-inflammatory agent for skin diseases, often used to treat everything from fever to ringworm. Alice Ball's genius was in taking those isolated acids and chemically transforming them into ethyl esters that we talked about. She essentially took the healer molecules that Power, Barrowcliff, and Andre had identified and gave them a way to travel safely through the human body, finally allowing the oil's calming and fever-reducing properties to work without the agony. Beyond leprosy, we're starting to realize that this chemical alchemist has a massive range. In 2018, researchers found that it can act as a stimulant, increasing alertness, while also serving as an anticonvulsant to stabilize the nervous system. It's effectively a botanical balancer, protecting the very nerves that leprosy seeks to destroy. In the world of dermatology, researchers are finding that Chaulmoogra not only clears lesions, but also helps repair the skin barrier and reduce inflammation associated with chronic conditions like psoriasis. There is even early-stage research into whether these compounds could play a role in future cancer treatments. We're also seeing it used in the fight against other pests. A 2023 study showed that the oil is a potent natural pesticide that's particularly effective at killing mites. It's a strange irony of history that we spent thousands of years terrified of this tree's toxicity, only to find that the very thing that made it so poisonous was the key to its power. But just as we finally mastered the chemistry of the Chaulmoogra tree, the world of medicine was about to undergo a revolution that would push our ancient jungle guardian into the back of the medicine cabinet. For all of its molecular brilliance, the era of the Chaulmoogra tree was probably way shorter than anyone expected. While Alice Ball's breakthrough was a lifeline, it was also incredibly labor-intensive because you'd have to hand crack the woody husks of the fruit to reach the seeds, which were then cold-pressed for the raw oil. But the chemistry that followed was the real bottleneck. To make the oil injectable, it had to undergo a grueling series of steps: saponification, acidification, and, the most tedious of all, recrystallization. The acids had to be dissolved and cooled repeatedly, sometimes dozens of times, to ensure every trace of the stomach-shredding toxin was gone. And this required specialized glassware, high-proof alcohol, and a level of precision that was really hard to maintain in remote clinics. Because the drug relied on a botanical source, the world's supply was at the mercy of weather, crop yields, and colonial shipping routes. By the 1940s, the medical world underwent a seismic shift as synthetic chemistry finally outpaced this botanical labor, and the Ball method was eclipsed by the rise of sulfons. Chemically, a sulfon is a functional group where a sulfur atom is double bonded to 2 oxygen atoms and 2 carbon groups. In medicine specifically, with the drug dapsone, this structure acts like a precision strike. While Chaulmoogra oil worked by disrupting the bacteria's metabolism from the inside out, sulfons worked by blocking the bacteria's ability to synthesize folic acid. Without folic acid, the bacteria can't produce DNA, which means it can't multiply. Unlike the natural oil, dapsone could be manufactured in a factory anywhere in the world in massive quantities with perfect consistency. Almost overnight, the sacred oil was rendered useless. But still, the Chaulmoogra tree maintains a sophisticated afterlife, of sorts in the 21st century. It's still a powerhouse for treating psoriasis, eczema, and persistent skin infections. Because of those unique fatty acids that penetrate deep into the skin barrier, you will find it featured in high-end anti-inflammatory serums and skincare designed to treat and soothe chronic redness. Meanwhile, visitors to the University of Hawaii at Manoa can find a lone Chaulmoogra tree on campus, marked by a bronze plaque dedicated to Alice. It stands as a silent witness to a stolen legacy, a reminder that the cure wasn't a gift from the heavens or a lucky find by the colonial hunters. It was carved out of raw toxicity by the sheer relentless drive of a young woman who had mastered a jungle's poison and gave thousands of people their lives back before she even had the chance to live her own. And sadly, despite its history, the tree itself faces an uncertain future. The IUCN currently lists several species within the Hydnocarpus genus as threatened due to habitat loss. The specific maritime forests they anchor are being fragmented by modern development and cleared for monoculture farming. We are slowly losing the genetic library that provided one of our first global cures. But there is hope. In its native India, conservationists and community-led sacred grove projects are working to restore these forest corridors, while botanical gardens are establishing specialized seed banks to preserve the genetic library of the Hydnocarpus genus. It protected us for centuries. It's only fair we do the same for it, don't you think? I'm Megan Brame. Thank you for joining me on another episode of The History of Plants. Jump into the commentary episode on Patreon to see other bonus content, or check out the Yaupon Holly episode to discover how another powerful native plant was nearly erased from history, not because it didn't work, but because it worked too well for the wrong people. Until next time, Greenies, stay curious and don't forget to flourish.